There we go. And let me reshare my screen just in case. So we've got to finish 5-5. There's really not a lot left, so it probably won't take that long, but we'll do it. I want to go over this one again really quick, partly because I actually got a number wrong when I did it the other day, and two, it was kind of rushed at the very end of class, so I just want to talk about it again. So remember, what we're doing in 5-5 is we're essentially using the fundamental theorem of calculus to be able to solve for the value of the antiderivative at a certain point. So essentially, we need to know the integral value and we need to know a value of the antiderivative. But besides that, we can find essentially whatever value we want, really. So in this one, we were essentially told that an initial population for this bacteria colony was 14 million bacteria, and we were given the rate that it was growing by. So the first thing we wanted to do was just set up that definite integral. But then if we want to find the population at 2, which would technically be the antiderivative of the rate of population growth, so we wanted to find the antiderivative, well, if we set it up in terms of the fundamental theorem of calculus, and so essentially the integral you want to set up, the bounds have to include the number that you know the value for and the number that you want the value for. So since we want the value at 2, and we actually know the value at 0 because we know the initial population, we would want to set up the integral from 0 to 2. Say we were told the population after 1 hour, we would use 1 and 2 instead of 0. So it depends on what value you're given and which one you want. But since we want to and we have 0, we set our integral up that way. And then since we want to solve for the antiderivative at 2, we have to essentially swing this f of 0 over to the other side. The one thing I got wrong the other day, because I typed it into my calculator wrong, is this antiderivative, sorry, this integral should give you 4.382. I had like 18 or something like that the other day. So you might want to fix that really quick if you still have the wrong number there. Oh, one thing, in terms of the final exam, so I need to pull up something really quick. In terms of your final exam, it's going to be open note, open resource, stuff like that. So in case anyone have a calculator that can do an integral, I want to show you how you can do it with Desmos. So let me demonstrate that really quick, because again, for these notes, we're pretty much almost done. So I'm going to take the time to do this really quick. So Desmos is awesome. Ooh. The final is online. All finals this year are online. So Desmos is pretty freaking awesome if you don't know it already. So it has a graphing calculator. It's also got a scientific calculator. But anyway, if you literally just Google Desmos, or it's desmos.com, so desmos.com won't bring you exactly here. Desmos.com would bring you. Nope, I gotta spell it wrong. Desmos. I spelled it right and then I got rid of the S. We'll bring you here. But then you just click on graphing calculator and it brings you the graphing calculator. So if you want to do an integral in here, you literally start typing integral. So you type an INT and it magically turns into an integral symbol, and then you just fill it out. So we wanted from 0 to 2 of 2 to the t, and for this one it doesn't matter what variable you use as long as it matches. So like if you use an x, then it has to be dx. If I use a t, then it has to be dt, but it'll spit out the value for you. So if you don't have a calculator that can do integrals, you'll be able to use this on your final, because I will ask you questions where you'll have to, like, integrals. Sorry, my English just broke. So like the one we were just looking at, you can't do that integral by hand because we don't know the antiderivative of 2 to the t. So there will be some questions on the final potentially where you have to use a calculator or a Desmos or whatever. So I'll probably also put up a reminder on Blackboard of how to use that for the final if you forget. But anyway, so jumping back to the notes. So anyway, that was I typed it in incorrectly when I solved it the other day, so that should be 4.382 instead of whatever the heck I had the other day. So the final answer turns out to be 18.382. Also, I guess I should say this one before we get into these last few examples. Well, I'll talk about that in a second. I do have your exams graded. I just haven't put them into Blackboard yet. Gwen, you haven't missed much. There was a typo the last time I did this problem, but that's about it. I've been rambling about the final. Oh, and now I lost my train of thought. Oh, dang it. Oh, I have your exams graded. Your grades should be into Blackboard by the end of the day today. I'll also update, the current grade that you have. I'll also upload a grade calculator so you can kind of put in the grade that you have so far and the grade you want to get on the final to figure out what you would need to get a certain grade if you want to play around with that. In terms of the final, so would you say the final evenly covers all the material from this semester? So this semester, I kind of think about it in kind of 3 pieces, 3 chunks. And the chunks are kind of the exams. So there was the exam 1, which was a lot of pre-calculus material. While that will show up on your final, that shows up a lot less than the exam 2 and exam 3 material, because exam 2 and exam 3 is actual calculus. So I focus more on the calculus stuff than the pre-calculus stuff, but there will be some exam 1 material on there, but I wouldn't say it's an even spread. I would say that exam 2 and exam 3.
Professor Hannah?
Yeah?
When is our final and how are we taking it?
Yeah, so someone else just asked that. I need to pull it up. It's in the syllabus, but so let me pull up the syllabus really quick. Boink. Boink. The 7th? That sounds right. Yeah, Monday, December 7th. December 7th at 12:30 p.m. So again, it's online because all of the exams are online. What I'm going to try to do before your final is I'm going to try to put a kind of a practice. It might not be content. There will be a review packet for the final, but probably not. So the thing I'm about, let me try that again. There will be a review packet for the final. That's not what I'm talking about right now. What I'm talking about is I might try to put up a example test. It might not be actual content, but at least so any of you who haven't taken an exam on Blackboard or something like that can get an idea of how it looks, because the final will be on Blackboard. So I'll put up like a spoof exam so you can get an idea of what that'll look like. And again, I'm not entirely sure the full format yet, but it is probably going to be a lot more multiple choice. There might be some of the find the error questions, but it'll probably be something where I like write the numbers, write a number next to each line and just say what line has the error in it. So that kind of deal. Once I get a better idea of like the types of questions I'll put on there, I'll let you know. But it'll be through Blackboard to the best of my ability. I'm not a big fan of Blackboard exams, but they've got to be online. Usually I try to write, so there's 2.5 hours for the exam, because that's just the time frame that the university gives. I usually try to write an hour and a half, a 2-hour exam, for the average person, quote unquote. So it probably won't take you the full 2.5 hours, but you'll essentially have that 2.5 hour block to do it. It'll be a timed exam. It'll be timed for 2.5 hours, even if it's not written to be a 2.5 hour exam. So yes, it's in 2 weeks. So if you're not already aware, so there's classes today and tomorrow, of course, and then Wednesday through Friday, it's closed for Thanksgiving. We have classes on Monday. You also have classes on Tuesday if you have Tuesday classes. And then Wednesday, Thursday, Friday of next week. So the 2nd, the 3rd, and the 4th are all reading days. So those are essentially just days where essentially nothing happens, but you can study. So that's a thing. But anyway. All right. Yeah, so we'll probably talk a bit more about the final next week. If you have any more questions, let me know. But otherwise, let's get into these last few problems. There's not many. So say we want to answer this one. Given f of x is x e to the x squared, and the antiderivative at 0 is 1/2. Find the antiderivative at 3. Now this one, in terms of a normal semester, you would be able to do the integral here by hand, but this semester we will not have time to cover how to do that. So this would be another one that's kind of forcing you to do it in a calculator. But anyway, so we essentially we want to set up an integral. Now we know the value of the antiderivative at 0, and we want the value of the antiderivative at 3. So that essentially forces our bounds to be 0 and 3, because if it's not 0 and 3, then we're not going to be able to solve it. Like, we need to know the value at the other point. And then our integrand is that function that we're given. So again, while there is a way to do this by hand, we don't know it. So you'd have to punch this into a calculator or into Desmos. So let me go ahead and jump over to Desmos and do it really quick just to demonstrate again how that works. So over in Desmos, there we go. We want the integral, so you type in int. Integral from 0 to 3 of x e to the x squared dx. So that's 4051.042. So if we jump back over here. So, okay, I should have written out another step first, but that's all right. We'll just do it like this. Why is there a decimal there? Whoops. Okay, something's wrong with my brain today. 0, 4, 2. There we go. So that's the value of the integral. So how we're going to use that is we need to remember that this integral is also equal to the antiderivative at 3 minus the antiderivative at 0. That's the fundamental theorem of calculus. So we want f of 3, so we need to get that by itself. So we're going to add the antiderivative at 0 over to the other side. And now we know both of the values on the left. We already calculated the integral, so the integral came out to be 4051.042. And the f of 0 we're given in the original statement of the problem. It's 1/2. I'm going to write that as 0.5. Whoops. I'm going to write that as 0.5 just because the other thing's a decimal and I want them to match. So our final answer for the antiderivative at 3 is going to be 4051.542. And that's going to be our antiderivative at 3. Questions, concerns about that? Okay. All right. So one of the contexts that this is going to be used for our purposes is in terms of cost, revenue, and profit. So remember that the derivative of cost is called the marginal cost. So if we have the marginal cost and C of 0, regular old C of 0 is the fixed costs, then the integral from A to B of the marginal cost is going to be essentially C of B minus C of A using the fundamental theorem of calculus. But what this is essentially going to mean is it's going to mean the cost to increase production from A units to B units. So it's the cost to increase the production is going to be what that integral represents. So remember way back when we were originally first talking about cost, revenue, and profit, we talked about the fact that there's fixed costs and also variable costs. So remember, fixed cost was essentially the thing you're paying no matter what, your rent, your electric bill, whatever. Cost for materials. And then the variable cost was the cost to make each item. So we've had a couple ways to think about variable costs, but now we're going to have a way to think about it in terms of these integrals as well. So the total variable cost of producing B units, so say you want the variable cost of producing 5 units or whatever, this is going to be the integral from 0 to B of your marginal cost. So if you want a variable cost and you know the marginal, you can find it using an integral. So if we wanted to find the total cost of producing some amount of units, that would tell us that C of B, well, if you think way back to when we first talked about this, it was always fixed cost plus variable cost. That still holds true here. So if we know that fixed cost is, whoops, why am I using an F, is whatever C of 0 is, and we just said that our variable cost is the integral from 0 to B of marginal, then that's how we can find the cost of B units. So this is essentially using that fundamental theorem of calculus and just bringing the C of 0 over to the other side like we were just doing. That's why it's related to this section. But so essentially, if we don't know the original function, but we know the marginal cost function, and we know the fixed cost at least, then we can be able to find the total cost of producing any amount that we want. We just change this B value. Okay. So I'll hold that for a couple seconds in case people are writing that down. So we've got one example of this, and I should check something. Let me pull that up really quick while I'm thinking about it. So say we have the marginal cost given in the graph below. So we don't actually know the equation for it. We just know the graph that we're given. And say we wanted to find the cost, the cost of producing 250 items. And we know that the fixed costs are $1,000. So we want to find the cost of producing 250 items. Well, this would be the fixed plus the variable. Well, the fixed costs were actually given. That's stated to us in the problem as $1,000. And then the variable costs, well, since we don't have the actual cost function, but we do have this marginal cost, we can think of it as the integral from 0 to 250 of C prime of Q. Now, we don't have the actual equation for C prime of Q, but we don't need it. Remember that the integral is area, so we can estimate the area underneath of this to get an estimate. We're not going to get it perfectly, but we can at least estimate it. Now here, we could technically do a Riemann sum. We would probably want to do a right hand and a left hand and then average them. It would be a little gross because we'd have to be estimating those y values. But instead, let's go and use that that counting boxes technique. So let me zoom in on this a little bit. So since we have this kind of grid structure in the back, let's kind of do that counting boxes doodad. So let's first count all of the full boxes that we have. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that's the end of all of our full boxes. So now we've essentially got to start kind of piecemealing them together, if you will. So we've got these two right here, this little tiny piece and then this mostly full box. So this, I'm on the right, this mostly full box over here, and then this little tiny sliver over here. If we group those together, those are approximately going to give us another box. So since we have 14 full boxes, and that gives us essentially another box, that's going to bring us up to 15. So we've got 15 boxes so far. And now we've got, oh no, how do we want to piece these together? If I take this piece here and group it with this guy over here, That would probably be a little more than one box, but approximately one extra box. So let's make that a 16th box, those two pieces together. This one's harder to draw how I'm piecemealing them together because with the other ones, they were usually right next to each other, and now I kind of have to scramble around a little bit. If I take this little sliver up in the very right corner and attach it to this guy right here, that would give us approximately a 17th box. Hopefully that makes sense. I've got in the left side, these two right here, the almost full box and the sliver next to it would get us about an 18th. And then for the rest of them, these two right here is probably 18th. And then what do I have left? I have this little tiny sliver and this kind of large piece right here. Now, bear with me. Since we're approximating here, adding that little tiny sliver to that other box is not going to get us a full box, right? Now, technically, that box down there is a little more than half a box, but for our sanity, let's just say it's about 19.5 instead of rounding up to 20. If you went with 20, I wouldn't say you're wrong. But for the sake of me just forcing us to do this, I'm just going to say, let's say, even though that's a bit more than half a box, let's just round it down to 19.5 boxes. Everyone okay with that? I know counting boxes can get a little weird. So I had 19.5 boxes is what I chose to estimate it as. Again, if you made it 20, I wouldn't hold you weird. But remember, when we actually want to find out what this integral value is, it's not just 19.5, because we want to take into account how much stuff is in each box. So if we then kind of look at the axes and how this is split up, these are 50 by 2 boxes. So each, vertical line is 2, each horizontal line is 50. So each one of these boxes is a 50 by 2 box. So we also have to take into account the area of each box, which is 50 times 2, so area per box. Which means that the actual amount of area underneath of that function is 19.5 times 15 times 20, so 1950, and that's the area. So that means that our integral value is, approximately 1950. So since we just found the integral value, which would give us our variable cost, we add that together with our fixed cost to get that the cost of producing 250 items is going to be approximately $2,950. Questions, concerns about that? Okay. That's the end of these notes. What I'm doing right now is I'm looking through, you have one last homework assignment. I'll say a bit more about that in a second. And I just want to look through it really quick and see if there's anything that really pops out as something we haven't touched on yet. Nope. That one's like this. That one. Do. Okay, maybe I'll do one like that. Oh, that one. I should probably do an example of that. Okay. When do we know when to piece the boxes together or to just find the integral? Okay, so if you have the equation for the function that you want to integrate, find the actual integral. Like either take the antiderivative or plug that sucker into your calculator. Here we didn't have an equation for the thing that we needed to integrate. So when you don't have a equation, you need to use the area technique. And since we had the kind of grid structure in the back, that kind of is what led me to the box counting instead of, say, Riemann sum. So that's kind of the difference, is do you have, what's the word? Do you have a equation for the thing you want to integrate or not? Any more questions about that one? Okay, so you have one last homework assignment. It's up on Wiley already. Because I don't want to have you guys trying to, you know, crush things over Thanksgiving weekend. I made it due next Wednesday instead of next Monday, so that you guys have a bit more time to. But I mean, we've covered everything. There's nothing new that we're going to cover anymore. So that's all up there. And I just want to, I'm trying to pull something up while I'm talking. I want to go over one other question that pops up on your homework. And technically you have everything you need to do it, but sometimes people don't realize they do. So let me get this really quick. Why is this not working? There we go. Doop. All right, where is it? Here we go. Okay, so undo that. Share. So you don't have this thing I'm about to pull up. You don't. It doesn't exist in your life. So if you want to write down some of the more important bits, I would say if you want to try to write this down, and I'll give you a couple seconds before I do the actual problem, I would just write this bit down. What? No, Kayla, it actually wasn't. But so if you want to write down something really quick before I start talking about this one, I would just write down the stuff in that box, because there are 2 questions on your homework that are like this. So I want to talk about it. So I'll give you all a couple seconds to write those down if y'all are taking that down really quick. All right, so, well, technically this full question is: a lab is performing tests for a new drug. They're testing how long the drug stays in someone's system. Let D of X be the amount in milligrams of the drug left in a person's body X minutes after administration. Let little d equal big D prime be the rate at which the drug leaves the body. Given the information below, evaluate the given expressions and interpret them in terms of the drug. So, now the thing that I boxed is essentially the information that you're given, and then the first thing that we're asked to find is this D of 0. So that's a capital D of 0. We have a capital D and a lowercase d going on here. So the thing we want to remember is that the capital D is essentially the antiderivative of the little d, which is essentially what this piece of information up here tells us. If we take the derivative of capital D, we get little what? If we take the derivative of capital D, we get lowercase. That's the word I'm more looking for. So capital D is the antiderivative. So if we essentially want this value of the antiderivative at 0, we can find that by taking an integral. So essentially we'd need an integral that includes 0 and then any other number that we know the antiderivative for. Now this one's actually interesting because you actually have 2 choices. We could use either one of these integrals that we're given. So actually, let me do both. So if we look at the first integral that we're given, this is, whoops. Well, okay, so that looks a little silly because it's dx. But this is technically, you know, the antiderivative at 4 minus the antiderivative at 0. So like this is the thing that we're looking to find. and the other two pieces we actually know. Like that integral value we're told in this set of information is -3. And then the capital D of 4 we're told in this piece of information is 5. So if we just do some algebra on this, we'll be able to find what D of 0 is. So I would add D of 0 over to the other side and then add the 3 over. So I'm about to run out of space. So let me just erase it. And then, well, no, let me just do full out. And then add the 3 over to the other side. So D of 0 that we're looking for would be 8. Now, again, technically you had another choice for this one. So let me just talk about that really quick. Well, let me hold on a second before I talk about it really quick. So the other choice would have been to use the other integral. And if this is written out correctly, this should give us the same value because that would make the most sense. So this should be capital D of 7 minus D of 0. And again, we're told all of these pieces of information. We have -5 is the integral, and then D of 7 is 3. So if we do the same type of algebra, equals 8. So either way, give us the right answer. So essentially, when we were looking for this antiderivative value, we know that the antiderivative value can be found from an integral. So since we know integrals that include 0, and we know the other value for that integral, so essentially, say they didn't tell us, I'm gonna white this out really quick and then bring it back. Say they didn't tell us what D of 7 was, then we couldn't have done that second integral, even though that integral included 0. Whenever you want to use that fundamental theorem of calculus type of deal to solve some of these, you have to have one of the values and want the other one. So if we wanted D of 0, but we don't know D of 7, then we can't use that integral. But we technically were given D of 7, so we could have used it. Questions on that one before I do the next one? Part 2. Oh, technically, this also asks me to interpret this. So capital D is an amount in a person's body after X minutes of administration. So if it's 0 minutes after administration, that's essentially the starting value. So the interpretation here would be, how do I want to phrase this? The initial value, I guess. The initial value of the drug in the system is 8 milligrams. There's 8 milligrams in the drug in their system at the beginning of administration. There's 8 milligrams of the drug after 0 minutes, anything that gets the point across of essentially 0 minutes, 8 milligrams. So the 0 minutes in my interpretation is wrapped up in the initial value phrase. Part B here is we want to know the integral from 2 to 7 of little dx. Now here, if you think about the fundamental theorem of calculus, we would love to be able to do D of 7 minus D of 2. Well, that's awesome because we actually already know both of those values. So we just plug in those values, we get -4. Now, what would that mean in terms of kind of this context here? So remember, interpreting an integral, it's essentially a total change. So this is going to be essentially the change in the amount of drug. So it's essentially saying that between the 2nd and 7th minute, 4 milligrams have left the body. So if I want to do it in the kind of the cookie cutter phrasing, I would say the change in the amount of the drug, change in the amount of the drug in the system, between the 2nd and 7th minute is -4 milligrams. So saying it in the cookie cutter language, as I kind of said before, doesn't really get the point across in decent English. A better way to say it would probably be something like between the 2nd and 7th minute, 4 milligrams of the drug will leave the person's body or something like that. But y'all know that I don't really care about whether or not it's good phrased English as long as it gets the point across. So there are 2 types of questions on your homework that are very similar to that, where you're just given a bunch of information and you're asked to find that value. Is there anything else on here that might trip y'all up? Interpret. Ooh, is that the one that Wiley hates? I think there's one on here that you have to type in an integral for, and I think Wiley is a little bit gross about the notation, but I can't remember why. So if it's not accepting your integral, just let me know and I'll look at it, see whether or not it's an actual mistake or Wiley just being a butt face. What is this one? All right, I'll do one more thing, and then we'll call it. So this one, let me just think of one off the top of my head. So where can I write this? Is there a space here I can write it in? I'll just squeeze it down here. Zoom. So say, just one last thing. Say we want to find the, say we're given marginal revenue. Let's not make it too gross. Let's do 6x squared minus 2x plus 1. And say you were asked to find the total revenue if there are, let's just do 20 sales. So there's a question very similar to this one on your homework as well. So if we want to know the total revenue at 20, we want R of 20. Now, technically, we could just find the antiderivative and plug in 20. But if we want to use this kind of fundamental theorem of calculus notation, what we would do is we would use the integral from 0 to 20 of, I don't feel like writing out that full equation, which would give us R of 20 minus R of 0. Now, if you think about it, revenue, when you sell no things, your revenue should be 0. Like that would make logical sense. I've never seen any situation where the revenue at 0 is not 0. So the revenue at 0 should be 0. So actually, if we just calculate this integral, and we don't even have to do it by hand now, we can punch that into a calculator. If we just calculate that integral, it's going to give us the amount of sales. Now, if this were, say, the total cost, that would be different, because then the total cost would include the fixed cost, and we would need to take that into consideration. But since this is revenue and the initial revenue is 0, we can just use this integral. So if we just calculate the integral of 6x squared minus 2x plus 1, either in your calculator or now you've seen it on Desmos if you don't have a calculator that can do so, that'll give you, so let me just figure out what the actual answer is. Your answer. Of course, you could take the antiderivative and plug in those bounds, but whatever floats your boat. So I think that's the only other thing that might have tripped someone up. That's not to try to say don't ask me questions if you have questions on your homework, but in terms of things that might be like, we didn't see one like that. Now I think I've caught them all. All right, so we're 10 minutes early, but we finished the notes a while ago, and I've gone over a couple of these. If you have any questions, feel free to stick around. Otherwise, we'll be done for today. I hope you guys have a great Thanksgiving, and I'll see you guys on Monday for kind of a review day for the final.